These functions will be learned by models called base learners, and we can choose what we want them to be. You've learned about decision trees before and how they can capture nonlinear relationships in data. The base learner can also be a linear model, or we can have two different models for the two different learners. Each of these models can learn using different parts of the randomized control trial data. mu1 is learned from patients who were assigned to the treatment arm, that's WI of 1, using age and blood pressure as the inputs, and Y as the desired output. Similarly, mu0 is learned from patients who were assigned to the control arm, use age and BP as the inputs once again, and Y is the output. Now, to train one of these models, we can divide up the data set into a training set and a validation set. Notice that these mu-hat models are actually prognostic models like you learned about in course 2, where mu1 is a prognostic model giving us the risk of an adverse event for when treatment equals 1, while mu-hat of 0 would be the prognostic model giving us the risk of the adverse event for when treatment equals 0. If you picked a decision tree for the base learners, then you might learn models that look like the following. Notice that both models are using blood pressure and age to output a risk score. We can see how we can use these models to now estimate the treatment effect for a new patient. For a patient who is 56 years of age and has a blood pressure of 130, we can get their expected risk using mu-hat1 under treatment. So we see that the blood pressure is smaller than 140, and we see that the age is smaller than 60, so we have a risk score of 0.21. On the right side, we see for this patient, age is smaller than 60 and blood pressure is smaller than 160, so we output a risk score of 0.45. Now we can subtract the two to give us the conditional average treatment effect for this patient, given their features. This is going to be 0.21 minus 0.45, which is negative 0.24. The method of using these two models, mu-hat1 and mu-hat0, and taking the difference between these two estimates to estimate the conditional average treatment effect is called the two-tree method or the t-learner.